Okay, let's start. So, Assalamu alaikum, everyone, and welcome to this webinar of the Best for Water Research, Water Systems Research seminar series hosted by the LUM Center for Water Informatics and Technology. If you have been regularly attending the sessions, then you already know that uh, uh, we've geared this seminar series towards distinguished research in water systems. And the topic for today's webinar is extremely very well fitted into what our philosophy for the overall webinar theme is. So before I introduce the speaker, I'll hand over to Dr. Abu Bakr, who is the director for the center, to introduce the session. So, sir, over to you.
Thank you, Talha, and Assalamu alaikum, everyone. From the participant list, again, I can see some wonderful people from sister institutes, Punjab Irrigation Department, Mehran University, and others. So welcome all. But most of all, we would like to extend a very warm welcome to Professor Mitchell. Professor Mitchell's research has been really outstanding. And really, there is a recent Springer book that came out, which has been edited by Professor Mitchell and has a very nice chapter written on the topic that we are going to discuss today, which is the same book where we also had a little bit of a contribution. And looking at the contents of those chapter, and of course the things that we have been doing at the center for some years, we thought that there is quite a bit of synergy in our thinking, and we have not formally talked to each other before. So this will be a wonderful opportunity to learn from each other. As far as this idea of socio-ecological systems research is concerned, this, as Salah mentioned, fits very well with the research theme that is going on within this series. Already we have had a couple of talks, one on social hydrology, another one on related theme by Professor Ariel Dinar, and others. And what really intrigues us at the center, of course, and hopefully you will learn more from Professor Mitchell as well, is this human water interactions as being central to these new emerging kind of insights. Traditionally, we have had water studies in Pakistan in this region, which are very sort of resource focused. And more and more, we are now beginning to see work which is at the interface. So on the sociology side of things, also good work has been done. So for example, the works by Professor Gil Martin and Professor Imran Ali long time back on the sociology of these irrigation institutes. But then really starting from the 90s, this work on devolution and participatory irrigation, that was backed up by some very good groundbreaking work by Ostrom and others on socio-ecological systems research. It was pushed by the World Bank. It was really supported by the governments here, and then it went nowhere. So 20 years, 25 years from there, I mean, we keep thinking, I mean, we do talk about these human water interactions in the academia, but it is very important to learn what is now happening. Is there a new state of the art that we need to learn about? Or are we really need to go back to those old principles that we have probably not taken a closer look already? And most of all, what has been happening around the globe? So Professor Mitchell's experience in Australia, I think that is very intriguing for us. We've looked at some of his papers. So hopefully he can show us some comparisons, so to speak, or maybe some good practices and some good design ideas. And we are very much looking forward to learning from Professor Mitchell, both about his research that he has done in Australia, as well as the wonderful work that we have seen recently coming out of Pakistan. So, Talha, if you want to go ahead, please take over.
Thank you, Dr. Abu Bakr. So before we begin the talk, let me formally introduce the speaker. So Professor Mitchell is a research fellow with the Charles Sturt University's Institute for Land, Water and Society. And as Dr. Abu Bakr has already pointed out, he has a growing body of social research experience related to natural resources management. He is currently leading an Australian government funded project project in collaboration with partner agencies in Pakistan. So not only is the field in which he working extremely relevant to this community which is gathered here, but also he has experience and is also currently engaged in working in Pakistan. From 2016 to 20, Professor Mitchell was employed on another Australian government-funded project exploring how to improve farming family livelihoods in Pakistan by tackling groundwater over-extraction. He currently teaches a subject on resilience thinking and sustainable development. So I look forward to hearing more about all of this in Professor Mitchell's talk. So before I hand over to him, just to orient the audience, so if there are any questions, there will be a Q&A session at the end of the talk for a few 5 or 10 minutes. So please use the Q&A button that you can see in your Zoom controls. So if you press that button, you will be able to type your questions. Feel free to type them in at any point during the talk. They will be logged and I can read them out to the speaker later on while the Q&A session is taking place. So thank you everyone for coming, and Professor Mitchell, over to you, and looking forward to hearing all about your work in the talk. So please go ahead.
Thank you, Tala, and I feel very honored and privileged to be able to give a presentation to you all. So welcome. I'm broadcasting to you from my home in Albury. Albury's on the Murray River that forms the border between New South Wales and Victoria. And that means that I'm on the land of the Wiradjuri people. And it's now customary for Australians to start proceedings by acknowledging that this land I'm on is Aboriginal land, land that was never ceded. So I therefore pay my respects to all First Nations elders, past, present, and emerging. Now, the Wiradjuri people have a saying which has become the ethos for my university, Charles Sturt, but it also provides a nice introduction to this lecture. The saying, Yindia Mawara, Winangangana, means the wisdom of respectfully knowing how to live well in a world worth living in. I think our research needs to be driven by a respect for our world, a desire to learn how to live well in our world, and with a purpose to make this world a better place that is well worth living in. So as introduced, my current research focuses on how to improve water and salinity management, and in particular for Pakistan, how its people can live well with salinity, but more on that later. So this talk will cover an introduction to the concept of social ecological systems and its origins, and then go through one of the tools that is used by social ecological system researchers, or SES researchers, which is conceptual mapping. I'll then go to Pakistan and provide a review of some of the learnings from the ASEA Pakistan groundwater project, and introduce the current project that just started this year. So to start with the concept, well, a basic premise, which I'm sure we all would agree with, is that all landscapes are the product of human modification. So they function as complex, intertwined, and co-evolving social and ecological systems. The social ecological system concept emerged out of research among ecologists, and in particular, the concept of ecosystem resilience. And for this, we have to go back to a fellow called Buzz Holling in the 1970s, who was tasked by the Canadian government to deal with a really big problem they were experiencing in their forestry. And that was a bug, a defoliating insect, the spruce budworm, that they needed to spray to kill, to prevent massive destruction of the forest. But what was happening is that they ended up having to spray tens of millions of acres of forestry. That's probably an exaggeration, but tens of millions of acres were sprayed annually at a significant cost. So when Buzz Holling was called in to see what an ecologist could do about the problem, he actually correctly identified that the control program was the problem itself. What that spraying had done was to set up a persistent semi-outbreak conditions over larger and larger areas. What it did is that the aerial spraying interfered with the predator-prey relationships. It killed the things that were feeding on the budworm, but it also ignored the internal self-control mechanisms of the budworm itself. So Holling observed that the problem was the spraying itself, and that was lowering the capacity of the forestry to deal with budworm. And so he coined this idea of resilience as the forest's capacity to cope with and recover from outbreaks. So this idea that came out of resilience spawned a whole lot of research. And essentially, from the ecological perspective, management of natural resource management issues needs to work with, not against nature. It also spawned a whole lot of research called adaptive management, and saw science as actively intervening in the natural resource management sphere. And it also spawned a journal, which was called Conservation Ecology, and is now called Ecology and Society. For obvious reasons, because as the researchers looked into the idea of ecosystem resilience, they recognized that we couldn't talk about ecosystem resilience without talking about social systems. So and that these two systems are constantly integrating. So the social ecological term was coined by a couple of Resilience Alliance scholars, and they come up with this term as one word to indicate that delineation between the two is artificial and arbitrary, but that both are important to analysis. So a hyphen was needed rather than using the system of a prefix like socio-ecological. And around about the same time, a number of other colleagues were doing something similar, and the acronym CHANS refers to coupled human and natural systems. So now I'd like to talk about one of the tools that we use. And importantly, the emphasis here is on research that is done with and for practitioners. So practitioners being the actual managers out there. And researchers and practitioners together analyzing and intervening in social ecological systems. And there are a range of workbooks now. The Resilience Alliance brought out a book about 10 years ago, a workbook, which is available on the web. They've also now developed a whole website that you can use, which is absolutely fabulous, particularly for practitioners. And it is even moved out into the NGO sphere. So the Mercy Corps has developed its own version of a resilience assessment called STRESS. So social ecological systems conceptual mapping. Well, let's start with an early example. And again, we go back to my neck of the woods. It's just down the road, the Goulburn Broken Catchment. Now, the Goulburn Broken Catchment is so step back. Victoria is very proud of the way that it's rethought how we manage land and water resources. What they did a couple of decades ago is maybe 3 decades ago now, is establish a process whereby managing land and water resources was done at a catchment scale. So the Goulburn-Broken catchment is one of a number of catchments for which catchment management authorities were established. So this example is also one of the first practical applications of the resilience thinking. And it's based on work by Brian Walker, who happens to be a long-standing friend of the family, and Paul Ryan, who also happens to be a very close colleague of mine with whom I've done a lot of work. So they were called in to help develop a strategy in response to a growing problem of waterlogging in the irrigation area, and concern that ongoing irrigation in the area may be on its way out. So this in particular is the irrigation area part of the catchment, which is a highly productive part of the catchment. So like Pakistan, the issue relates to a rising water table and associated increase in areas affected by salinity. But of course, it's much more complicated than that. It depends what part of the landscape you're talking about. So this is the model they developed. And what they did here is to understand, to represent what was happening at a range of scales, from the farm scale to a catchment scale and beyond. But they also tried to understand things from a range of perspectives. So understanding the biophysical sphere, what was happening in the economic sphere and the social sphere. So this example also happened to be the first foray amongst resilience scholars into the social sphere. And I would say it's a fairly minimal effort. So the model focuses on what's called thresholds of potential concern. And this is another tool that's used in resilience analysis. So they're really the tipping points that might push a system over into a new mode of operation. And that shift may even be irreversible. So you can see at the bottom, there is a threshold here, which is to do with the tree cover. Now, this is a classic understanding of what drives rising water table. You remove the tree cover and the water table rises. And indeed, parts of the Goulburn-Broken catchment, and this particular bore hydrograph shows it very clearly. People in those areas were alarmed with what was happening. They just saw the rising water table and it was reaching the zone which can affect crop productivity, the salinity risk zone. So the rising table brings salts with it into that risk zone, and this thus threatens farm financial viability. So we have a threshold here related to that, which is driving another threshold, which is farm financial viability. But then on the other side, as ecologists, they also saw some other thresholds of concern to do with biodiversity due to the loss of native vegetation cover, and both the changes in area salinized and tree cover was pushing the whole riverine ecosystem into a dangerous state, which is also affecting the rivers that flow through the catchment. Interestingly, if you know much about what's happened in Australia, the great scourge of salinity seems to have mostly been resolved, and that has a lot to do with a decade of drought that we had in the 2000s. We were very privileged, me and my colleagues from Pakistan were very privileged to meet with some of the people from the Goulburn-Broken Catchment Management Authority and learn a little bit about their current interventions. And it's kind of interesting. They still use the old groundwater pumps to pump out groundwater where the water table is close to the surface. But interestingly, they're doing something different as well. They've created what what could be called soft drains. And these soft drains have been created in the landscape to follow what were the old creek lines. So they've actually tried to find where the old creek lines were, and to build drains along those creek lines. And this is so that it helps to flush rainfall across the surface. But it also enables water to filtrate down into the landscape in a way that would have naturally occurred according to the geology of the landscape. But the challenge here, of course, is social. To build these soft drains means they need to access private land, and this means they need to secure agreement from the farmers that this is a good idea for the catchment as a whole. In other words, it requires collective cooperation from the whole community. And just briefly, I'd like to pop over to the other side of the river. So this is in New South Wales, and the equivalent Catchment Management Authority that covers part of the Murray Basin. I worked with them on their strategic planning, and we had a great team, including Paul Ryan. And one of the things that they wanted to do was to have a better understanding of their landscape, and in particular, the diversity of landscapes across their area of responsibility. Now, defining these landscapes involves both the natural landscape and the social landscape, which meant that to identify the diversity of landscapes across the region meant talking to their communities about how they perceived their landscapes. So through this community engagement process, the CMA was able to identify a set of landscapes with their own distinctive social ecological characteristics. And this is represented in this diagram here. And a couple of points to notice with it: they're fuzzy boundaries. There is no set defined boundaries, but also they don't actually, if you know very much about the administrative boundaries, they don't always match the administrative boundaries, nor do they always match what would be perceived as the natural landscapes. So they saw this as an interesting exercise, and it helped them with their strategy, their planning strategy. So some more examples of conceptual mapping. I'll go through these quite quickly. Of course, you can't see this one, but I'll blow it up in a minute. But this is an interesting one because it is one that seeks to unravel the complexity of a social ecological system involving a basin similar to the Indus Basin, the one across the border in India. And you can see that it's divided into boxes, and the bottom box is the biophysical system. And you can see some classic understandings that you would be familiar with in the Indus Basin. You know, there's flood events and what might cause them, and what might make them become worse. The link with lateral migration, the rise of the riverbed, the attempts to flood to control the floods through embankments. All of these things would be familiar with you. And similarly, sediment load. There's a whole lot of things that is making the sediment load increase, which is causing the rise of the riverbed and the tendency to. All of this is nothing new to you. It's just a way. It's just conceptual mapping provides a way for everybody to articulate what's happening and to see it. This is their effort to describe the social sphere. And again, it's kind of interesting that there's a description around the settled agriculture. So, you know, a lot of understanding of what's happening with rice and the cultivation of rice, and growing populations, decreasing the availability of land, but increasing the need for rice. But interestingly, there's some legacies that they've explored here. So the legacy of the hill dwelling culture, legacy of riparian culture, stuff to do with customs. So it's an interesting way to extend beyond the biophysical understanding of what's happening in the basin to also try to understand what's happening within the social sphere. This is another example that attempts to bridge across the biophysical world and the social world. And you can see there's a green box, which is describing ecological resilience, blue box looking at individual socioeconomic aspects, and the red box looking at what I would call governance, so that the local institutional capacity. And yeah, it looks really complicated and messy, but my students have tackled this, and it actually boils down to a few simple ideas which they can easily articulate. And what's also really nice about this particular social ecological system map is that this was done with the farmers involved. So this is looking at pastoral land in Nicaragua, and they actually got the farmers involved in a workshop to identify what's driving change and to identify the links and to create this map by themselves. And this is just one I came across recently. It's much more a research-driven one, but why I like it is that it really puts things in the big picture perspective. So behind a lot of stuff that's happening on the ground, as one of my students noticed, it's sort of really interesting to explore what's happening on the ground, the sort of light blue and the green colored aspects. But what's driving change here is really some very big picture stuff to do with globalization, economic growth, and natural resource scarcity. And the issue here is a mountain area in South Africa, which is experiencing an abandonment of the land, a move away from grazing, but a move towards something else, and what's driving that. And they use this as they describe in the title of the paper to present a more nuanced view of what's happening. So this kind of mapping is a thinking tool to help analyze and intervene. It helps identify feedback loops. So it's really about supporting non-linear thinking. And it helps to dig deeper to find the root drivers of change. So by constantly asking, well, why is that happening? You get to find out another driver of change behind the driver that you think is causing the change. It considers slowly changing variables and thresholds of concern. And in creating that, there's always a balance between complexity and simplicity. What are the most important drivers of change? And you get the debate between the lumpers and the splitters, those who like to bring things together into one, and those who like to disintegrate everything into little boxes. As you saw with that last example, it's useful for enabling stakeholders to understand their complex systems. It can also be used to develop quantitative analysis, as Sivapalan has previously presented. They've done a lot of work in that area. And as you can also see that it's been used for planning and to develop what-if scenarios. So I hope I've got a bit of time to quickly talk about my other area of research. This was a 4-year project we were involved with focused on biodiversity. So we're moving a little bit away from water management. But it's interesting because we were looking at 2 case studies. One was the Australian Alps, which is mostly national parks, protected areas, so government managed land, and the Tasmanian Midlands, which is privately owned land, farming land. And the biodiversity that we were seeking to consider in the Australian Alps is that area above the tree line, which involves some of the wetlands that feed the Murray-Darling Basin. And in the Tasmanian Midlands, it's a particular kind of ecosystem that is critically endangered. The pockets that remain in that area, obviously only pockets because the rest of the land has been converted to cropping. But the pockets that remain under climate change will no longer be able to survive where they are. But the opportunity exists that they may be able to be recreated in other parts of the landscape where the climate change conditions would be more conducive. So we get to this really interesting question, which was the social scientists' question. How do we decide the future for biodiversity in these places? So when we came to do a social ecological system map for this, we realized that the history is a great deal of focus on the ecological. And while there's been a bit of an increase of interest in the social and capacity in the social, this aspect of governance about who decides, for whom, for what purpose, and in whose interests remained really small. So we sought to create social ecological maps which focused on our biodiversity features, then categorize the biophysical drivers of change and the social drivers of change, but to really tease out what's happening in the governance sphere. What are some of the levers from governance that we can use to influence the system? So the maps we came up with for the Australian Alps, essentially, it's quite clear that what's impacting that particular ecosystem, climate change, which in turn is rapidly changing the fire regime. So we've had an increased severity and an increase in a number of fire regimes that affects the ecosystems, but also it's changing the pest regimes. Interestingly, the key governance influence, because this is a protected area, are the plans and programs themselves. They can influence how fire regimes, how we manage the fire. They influence how we manage the pests and directly manage the ecosystems themselves. And behind how effective these plans and programs can be is, of course, a whole myriad range of other governance influences: support of political will, vision, resources, legislation. And underpinning that, if you keep asking what would make the change, is a key one that the stakeholders identified. So this was done together with a range of stakeholders. A key one that they identified was community values and attitudes for the national parks and their ecosystems. In the Tasmanian Midlands, the particular ecosystem, again, affected by climate change, but critically, this is to do with the land use mix on private land. So there has been a shift away from grazing, which could provide greater opportunities for this ecosystem, towards cropping, and irrigation is feeding that. But the thing that we saw as a pivotal change agent is a social driver of change, and that is landholder engagement in conservation practices. And the Tasmanian Midlands is actually a really interesting area where there is both efforts to change the way that they practice their agriculture, but also a great investment in protecting parts of their farmland specifically for conservation. So we moved to Pakistan, and I hope I've left enough time to really delve into what we're doing in Pakistan. So yes, this chat about our Pakistan groundwater project stems from the chapter that we wrote in the book that was described. But before I go into our chapter, it's important to explain that this was a project funded by the Australian government through its flagship project, the Australian Centre for International Research. Flagship organisation, I should say. Flagship because it comes under the Foreign Affairs and Trade and is widely regarded across the Asia Pacific and parts of Africa for what it does in terms of research for development. And its approach is different. It's not the sort of classic bunch of multidisciplinary people who get together and decide what the problem is from their different perspectives, do a lot of research, come up with some outputs, and then hope that a research user will take those outputs on board. What we have done in the groundwater project, and what ACR does in all its projects, is make sure that the research user is there at the start to define the problem, and then works together in a much more integrated and interdisciplinary way together with the researchers users as required to end up with an output that is owned by the research user. So it involves a process of co-design, co-inquiry with research users, as well as the beneficiaries, the farmers themselves, for sustainable practice change. So our aim is really around building capacity of a whole bunch of people to improve groundwater management. Our objectives were firstly to get these bunch of people to develop and articulate a shared understanding of the problem. We then had another objective, which was really around what tools and options we could come up with. And that was done together with the provisional irrigation departments that are responsible for groundwater management, as well as others. And then the third objective was to make sure that there was enough capacity and institutional arrangements for post-project adoption of these tools. So this is research for sustainable practice change. And this is where it comes to the social ecological systems analysis. And this is indeed borrowed from my good colleague, Paul Ryan, this particular iceberg diagram. And what social ecological systems analysis trains you to do is to look beyond the symptoms of the problem, the events that you see. And in the case of groundwater, well, there's clearly groundwater depletion, there's waterlogging in some places, salinization, and the use of groundwater, bad groundwater can have effect on crops. The purpose is to look below the water, if you like, to understand what are the underlying causes of these symptoms that we can see. So if we're doing research for sustainable practice change, what that means is we need to ask, well, whose practices are we trying to change and how? So if we look below the water, if we look at the underlying causes of the symptoms that we're seeing, well, clearly there are some patterns of behavior that are contributing to the problem. So therefore, we need to work with water users, working with farmers to explore practice change with them. But importantly, their behaviors are driven by the systems and the structures that decide the paradigm in which their patterns of behavior can exist. And the water managers, as responsible for determining the kinds of opportunities and behaviors, are also contributing to the kinds of things that we see on the surface. So we therefore, critically and importantly, have been working with agencies to explore practice change with them. The bit that we probably didn't do in this project was to get down to the real paradigms, the ways of thinking, getting to the questions of decision-making and who has power. So in that sense, we need to be working at all levels to change the way practices are determined. So the chapter that we wrote is a reflection on what we learned at the end of the project. And what we're trying to do in this project is to build partnerships across disciplines, known as interdisciplinary research, to build partnerships between researchers and research users, which is known as transdisciplinary research, going out into the real world, if you like, working with social actors, managers, people responsible for what happens in the real world. And then thirdly, going beyond that to building partnerships among researchers, research users, and research beneficiaries. So building partnerships between the irrigation departments, the researchers, and the farmers through co-inquiry and actual research that intervenes in the system. So our learnings, well, in terms of interdisciplinary research, we had some effective integration between hydrogeologists doing groundwater modeling and our agricultural economists who helped with farmer planning pathways, and from our team, the social sciences, to determine strategies for farmer community engagement. But on reflection, even though we had environmental scientists with us on the team, the missing link here was that we never really used that expertise to understand the potential to explore what might be called nature-based solutions. In terms of transdisciplinary research, clearly a good success in that we had provincial irrigation departments being active researchers with us throughout the project and acquired the capacity to continue post-project. But as hinted, the missing link here is that we were never really able to start exploring the more challenging questions around power and paradigms, aka governance. And lastly, among researchers, research users, and research beneficiaries, well, yeah, we established some good networks, and some are ongoing. And we saw some uptake of some of our more practical on-farm tools, such as the mobile app we produced and some of the monitoring tools that we had available. But again, I think the missing link was in terms of engaging farmers in understanding their system. From a place-based perspective, there were elements that ecology could bring to a systemic understanding of that context. And I think I'll make sure I've got time to introduce our current project. Oops, I've jumped ahead in haste. So this project is starting this year. It's going for 2.5 years. It covers the southern Indus Basin, which, as you would know, is a very varied landscape. So what is the salinity issue that we're dealing with here, and what's causing it? Well, first of all, I have to say I'm not a salinity expert. I'm a social scientist, but I choose to collaborate with others with relevant expertise. And the first message I have heard is that the exact nature of the presence of salinity varies considerably across the landscape. And another key message is that salinity is an entrenched part of the Pakistan landscape. It has always been there, and they call this primary salinization, which is different from secondary salinization, which is primarily a result of the significant increase in salinity brought in because of irrigation. So in our area of focus, we are working with farmers in southern Punjab, so where this picture was taken. And this part of the landscape is primarily a result of the latter. It is irrigation induced. This area is at the tail end of the irrigation system, but there's also problems due to poor drainage and other things. We're also working, so this farm here is in an area which is serviced by the Malwa distributary in Sindh, and we've been working with them as part of the groundwater project for some time. And the issue here again is irrigation induced, but there's also the problem of the presence of high water table and waterlogging. And some of that high water table waterlogging is involving saline water. So this student picture here is working with farmer to understand the variable presence of salinity at the property scale. And then finally, we're also working in the coastal areas of the Delta. And this is an area affected by seawater intrusion. And this picture is taken on one of our early trips to understand salinity in Pakistan. And this involved a visit to this farm run by a very wealthy and progressive farmer who'd found a way to manage the delicate freshwater lens that sits on top of the saline groundwater below. This freshwater lens is replenished by the annual monsoon rainfall and is thus dependent on it. The farmer is managing to grow a healthy crop of chilies and other vegetables by carefully managing water pumped from below, then pumping out the drainage water and remixing it with fresh water for reapplication. In other words, he is actively intervening and adaptively managing his very limited water resources. So The background to our project: mega projects to fix the problem have not worked in the past. And I thank Dr. Ali for this review, pointing me to this view. An independent evaluation of 5 mega projects to fix salinity found that the success rate was low and sustainability of the projects was questioned, and offered some lessons from which we have also taken our lead. And the lessons learned is that large-scale complex projects and low institutional capacity constrained their implementation. Importantly, farmer participation was lacking. The framework to learn from doing fell short, and so salinity continued to persist. So our project involves a strategy of a change in strategy from eradicating salinity to living with salinity. So we're looking to adopt a holistic approach where farmers and researchers collaborate in systemic co-inquiry. I think I've run out of time, but it is intended to launch a 10-year project, a program. We have a process of developing a systemic and shared understanding, like we did in the groundwater project, and this time looking at current and future trends, both biophysical and social. We're looking to identify, to investigate adaptation options with farmers. And we're also doing that research, that social science research question around capacity building. And at the end, we hope there will be improved knowledge. We hope the community level understanding will have improved. We will hope that communities will have started planning their own futures for living with salinity. And importantly, that people, potential partners, government departments, will be supporting what's happening locally, and working with us to create a set of future projects that can scale out our approach to living with salinity. So my take-home messages: all environments have been modified by humans. Research can be active adaptive management. So it involves human interventions, but human interventions can be more effective when we work with nature, not against nature. They can be more effective when we engage society, those who will use the research and the intended beneficiaries. And ultimately, the context for that human intervention are complex, co-evolving, and constantly changing, which is why we need to be able to have the tools to understand the dynamics of social ecological systems. Thank you. There are some references.
Thank you, Michael, for the wonderful presentation. So for the audience at this point, we now invite any questions that you may have. I see that no one has raised any questions yet, but please feel free to type in your questions and we can read them out. Yeah, so so Michael, just maybe I can begin. So first of all, it was a very very interesting talk, I must say, and especially the it's really the philosophy, right? Just to view something as a system with these interconnected components, and just regarding every system as co-evolving with one another. And I really like that emphasis that you put not on the hyphen of social, of not socio-ecological, but it's social and ecological. So the hyphen is very important there. So you mentioned in the beginning that within the conceptual mapping practitioners, you have these lumpers and these splitters. So we often do a lot of this sort of conceptual mapping in our work, and we are often always confronted with this situation as well. So you sort of start to to understand, you begin to split and dissect the system, but where do you stop you stop dissecting and then begin synthesizing. So where is the margin really?
I think there's some sort of frame fees. I think we can see that.
Yeah.
So I think maybe Michael would be trying to get back to the presentation. Meanwhile, and we've just lost him. So Talha, I think a lot of what we have seen today is very familiar from, for example, the kind of courses that you have taught at LUMS as well. So maybe we can probe with. Oh, he's back. So please go ahead. I think maybe we should have a question for him.
Yeah, sorry,
Yes,
I got cut out for some reason.
Yeah, Michael, we lost you somewhere. So were you able to hear the question?
I got as far as lumpers and splitters and the challenge of doing that. Is that essentially the question?
Yeah. So that's the question. How do you where do you stop?
So a good example of that is the maps that I showed of our work in the Australian Alps and Tasmanian Midlands. What I showed you there was the simple map. One of the Tasmanian Midlands map that I showed isn't actually published. We published the much more complex and difficult map to understand. And those maps themselves were the product of a great deal of research where we came up with, doing a literature review of a number of what we saw in the literature that was driving change in those systems, and evaluating the importance of them by ourselves and testing that with stakeholders and bringing them into the discussion. And then what we eventually did as part of the workshop to create scenarios, we actually got the participants to decide which were the most important drivers of change through a simple voting exercise. To bolster that, we then asked them a really difficult question in terms of the scenarios, which was which of those drivers of change do you think is the most unpredictable to assess for the future state? I know I didn't explain that very well. It's a very challenging thing to explain, but we were going to go 30 years into the future and decide, okay, can you imagine the state of that particular driver in 30 years' time? If you think it's really difficult for you to imagine the state, then that's a really uncertain driver. So it was a measure of uncertainty. And what we did then was to create scenarios around those most uncertain futures, those futures against those most uncertain drivers. And that enabled us to create a diverse set of futures, which we were then able to use to test against governance. So the short answer is, yeah, you can do both the lumping exercise, which is what we did to create the simplified version of our mapping, but you can also, in our workshops, we also did voting exercises to be able to identify what's most important.
Okay, thank you. Very interesting. So I see we have a question from the participants. So it's regarding your SCR project. So the question is, I'm going to read it out. Is this project considering the Indus Basin as holistically or just Pakistani region? For groundwater, is there any impact from transboundary water usage?
Of course there is, and there's a wonderful chapter in the book which really delves down deeply into the whole question around groundwater and groundwater governance. Firstly, written by the same person. There's a chapter on groundwater governance, but also the arrangements to do with transboundary water management in the basin. So yes, quite clearly, just as there is transboundary issues with surface water, there are transboundary issues with groundwater. But interestingly, there's a message that an underlying message that comes through from that chapter that applies for Pakistan as a whole. There are some real questions around shared benefits of the water resources, I think, is the message of the chapter. Given the transboundary questions around sharing the benefits of the Indus Basin, there are also the same questions that need to be dealt with within Pakistan.
Okay, thank you. Let's move on to the next question. So I'm reading it out now. So thank you for the very interesting talk. How do we go from the conceptual social ecological model and causal loop diagrams to the management decisions? Are people convinced by the causal maps or maybe the non-intuitive findings?
Yeah, a good question. So again, I can speak to the Australian Alps and Tasmanian Midlands examples best. I think the conceptual mapping process worked very well in the Australian Alps. And I guess that's understandable because most of the stakeholders we had in the room were people responsible for managing that landscape. So there were a large number of the National Park Agency people in the room. And understandably, they would all be people who have backgrounds in ecological studies, environmental studies, and in some cases management studies. So they could go beyond the things in the diagram to start seeing potential management interventions as a result of those diagrams. It was more difficult in the Tasmanian Midlands, even though, again, we did have government agencies involved as stakeholders. And as my students pointed out, there were actually mostly government stakeholders in the room and not very many farmers in the room, which is always a challenge. But in that context, there was more difficulty in being able to see, because I think the drivers of change were much more around the social sphere, and it's very difficult to intervene in the social sphere. But also the biophysical aspects were a little challenging. And so at a time when the Tasmanian Midlands is pushing irrigation, we were looking at it as outsiders, particularly us from the Murray-Darling Basin, saying, well, not sure irrigation is going to be the solution.
Yes, that was a very interesting answer. So I was wondering if yeah, yes, I see we're running out of time. So maybe Dr. Abubakar, if you have.
Yeah, I would like to, I was just curious about something. So in much of this socio-ecological systems research that we have recently been looking into, there is this very strong theme of unintended consequences, that you try to do something in good faith, and then down the road you find out that things have not really worked the way that that a particular agency or a group of people, even though very well-meaning, it turned out that things have gone in a different way. In your work, have you found similar examples, and or even in your modeling and these causal loop diagrams and all that? I mean, one of all the tools that you use, do you explicitly look out for these unintended consequences? So that was the question.
Yeah, and just before I joined this discussion, I actually did have a listen to Zivapalan's presentation before, and I really encourage those from my team to also listen to that presentation. Yeah, unintended consequences, which he describes quite well in his presentation, is certainly a driver behind doing social ecological systems research. So I can't think of a particular example where there has been an unintended consequence. We're very aware of that with our salinity project, because we're intervening, testing adaptation options, which means intervening in on-farm properties. We're working with farmers, and we don't know. The kind of tests we might do may not work and may cause harm. This is a risk. And we need to be able to be aware of that and be responsible for that, because that involves a particular person's livelihood. And, we need to enter into such arrangements in good faith. I think more broadly, what we've tried to do in the scenario planning aspect, which I didn't really describe, but one of the consequences of scenario planning is being able to think about governance arrangements that can cope with unexpected events and unintended consequences. So the whole rationale behind our using those social ecological systems maps to develop scenarios was to be able to test whether the governance arrangements of the future would be able to adaptively manage in response to unintended, unexpected events, unintended consequences, and unexpected events. Yep.
Okay, thank you, Michael. And so I see that we're now out of time, and unfortunately we have to wrap up the session now. And thank you everyone for participating. And I just want to let you know that in case you missed out something from the presentation, Michael has kindly agreed to our hosting of the recording on the website, so you can always view it there, and please feel free to share it to other colleagues as well. And we also have some excellent speakers lined up for subsequent talks as well. So we hope that you will keep on following the series, and we also hope to see you in other sessions as well. So in the end, I also would like to thank Professor Mitchell, who took out time from his busy schedule to be with us, and it was a very insightful talk, and I hope it was the same for all of the audience as well. So thank you, Michael, and
Thank you.
for all of the audience, thank you for listening and being with us. So with that, take care and Allah Hafiz.